Alright, so welcome to the wonderful world of trigonometry. The big thing you're going to remember for all the trig stuff we're going to do, and I know I've said this 100 times in class, I'll probably say it 100 times more, is we want to remember SO, CA, TOA. It's a little acronym that we're going to use to remind us what the sine, cosine, and tangent stand for. And there's a reason I wrote it like this, and you'll see that as we go through this problem. So first up, they're asking me two questions right off the bat. They're saying find the sine of x and find the sine of y. Let's not worry about the sine of y for right now. Let's just worry about sine of x. So I want to go ahead and circle that angle because that's where I'm going to be looking right now. And the names of the sides of my triangle are going to depend on what I'm looking at. So the three names I'm going to give my triangle, or the three sides of my triangle, are hypotenuse, opposite, and adjacent. Every triangle will have those three names. I always find my hypotenuse first because that's usually easiest for me. It's a side that's across from or opposite of that right angle. So there's my hypotenuse. It's the longest side too, so 17. Next up I find the opposite side. That's the side that's across from the angle that I circled. So in this case it was angle x because that's what I'm working on finding. Imagine if you were to walk away from that angle, the side that you would run into would be the opposite side. So that 8 is my opposite side, and that leaves me with one more side, and the leftover would have to be the adjacent, which adjacent just means next to, so that 15 is the side that's next to the angle. Some people say, well, the hypotenuse is next to it as well, and I say, yeah, but the hypotenuse is already named. It has its name, it likes its name, it's not going to change its name, it's hypotenuse. So there's the name of my three sides. So the question was to find the sine of x. So I'm going to now be using SOHCAHTOA. The SO part of SOHCAHTOA tells us that we're going to be finding, well, S is for sine of angle x. The O says do the opposite side, which we're saying is 8, and divide that by the hypotenuse, which is 17. That's the ratio we're looking for. When they say find the sine of x, we're finding the ratio of 8 over 17. Now you'd simplify that fraction if you could. 8 over 17 can't be simplified, but notice in the directions, they also want the decimal rounded to 4 decimal places. So I'm going to do that on my calculator, do 8 divided by 17, and get a decimal of 0.4706 if I round off. So there's the sine of x as a fraction and as a decimal. Now remember though, they had also in the directions asked us to find the sine of angle y. So at this point, I'm going to erase some stuff in here. I'm going to erase the angle x that I was looking at. I'm going to erase opposite and adjacent and hypotenuse because those names may change now that we're looking at a new angle. So let me switch colors here too. Let's do blue. And I'm going to circle angle y because now that's where I'm going to be looking to find the sine of angle y. Well, one of your three sides will never ever change its name. That's the hypotenuse. It's still 17. But take a look at what happens with opposite and adjacent. If I were to walk away from that angle, I would run into this side, making that the new opposite side, and making this, the 8, the adjacent side. So be careful. Depending on the angle you're looking at, your opposite and adjacent may change names, but your hypotenuse will want. So again, they want to know the sine of y. The SO part of SOHCAHTOA tells us we're going to find the opposite side and divide it by the hypotenuse. The new opposite side is 15. The hypotenuse is still the same, that's 17. Simplify that fraction if you could. 15 over 17 can't be simplified. They did also want that decimal, so divide to find your decimal. 15 divided by 17 gets you 0.8824 if I round that off. My decimal point didn't really show up. There we go. So there is the sine of y. If you think you got it, the next two examples will show you the cosine and will also show you the tangent, so using the other parts of SOHCAHTOA. Try those if you think you got it. Otherwise, let the video run through and I'll show you how to do a cosine example and a tangent example as well. The cosine example, as you can see, is also going to involve something because we're missing a side right there. So pause if you want to try these. Otherwise, I'll keep going in about 2 seconds. So the first thing I'll need to do then is, well, I guess let's figure out what angle I'm looking at. They want to know the cosine of r this time. So let's circle angle r, that's where I'm looking, and then figure out the names of our three sides. If I were to walk away from angle r, I'm going to run into this side over here, making that the opposite side. So 12 is the opposite side. The side that's right next to that angle, right here, is going to be your adjacent side. And then the hypotenuse is the remaining side, the side across from the right angle. Well, when I go to find the cosine of angle r, thinking back to SOHCAHTOA, I'm using the CA part of SOHCAHTOA, which is adjacent over hypotenuse. So looking at my diagram, I see the adjacent side is 9, and I see the hypotenuse is blank. Uh-oh. So I run into a problem. I don't have the hypotenuse. Rather than leave it blank or leave a question mark, though, remember, we do have a method for finding the third side of a right triangle. Do you remember it? Did you just say Pythagorean theorem out loud? If you did, you're right, and you're probably a weirdo for talking to a video, but whatever. So I'm going to do Pythagorean theorem. 9 squared plus 12 squared is equal to, I'll say c for the hypotenuse for c squared. So I'm going to do some Pythagorean theorem to solve that, or I know that 9, 12 make part of a triple. I know that remaining side would be 15. If you didn't know that or don't know that, go ahead and do Pythagorean theorem and prove it to yourself, but that missing side must be 15. So going back to finding the cosine of r then, I can say that that missing side is 9 over 15. Remember, always simplify fractions. This fraction can be simplified. 9/15 simplifies to 3/5, and yes, you must simplify your fractions. They also wanted that decimal to 4 decimal places. Well, 3 divided by 5, 3/5 is just 0.6. If you want to put 0.60000, fine. Otherwise, 0.6 is fine because we didn't have to round anything off. So there's the cosine of r. And again, I'll do one more example with tangent. If you want to try that one on your own, now's the time to do it. Otherwise, just let it keep playing, and I'll do a tangent one. Again, start with finding the angle you're looking at. They want to find the tangent of k, so tan k. So there's the angle I'm looking at. So circle that first because the names of your sides will depend on that angle. First up, hypotenuse is labeled this time. We don't have to worry about Pythagorean theorem. So there's my hypotenuse. The longest side is 40. The side opposite angle k, across from angle k, is this down here, so that's my opposite side, 32. And finally, only one option remaining, and that's the adjacent side, which is right next to the angle. So I'm asked to find tangent of k. Look back at SOHCAHTOA, or have it memorized. The tangent, the TOA part of SOHCAHTOA, tells me I need to find the opposite side and divide that by the adjacent side. So we've labeled the opposite side as 32. We've labeled the adjacent side as 24. Always simplify your fractions. 32 over 24 simplifies to 4/3. And yes, you must simplify. They also wanted the decimal to 4 decimal places. I see that's 1.3 repeating. Some people ask me, can I just do that? And yeah, that's the answer. Because they said round it, I would just go ahead and do 4 3s, but I wouldn't mark you wrong if you put 1.3 repeating. So there's my tangent ratio. Remember, SOHCAHTOA, you're going to hear that over and over and over again, so make sure you know it and know how to spell it.